What astronomers learned and didn't from seeing a white dwarf switch on and off. The team hopes that this discovery will help us understand the physics behind accretion, how black holes and neutron stars feed material from their nearby stars. If you can stay alive for another 10 billion years, you can see our sun use up or burn all its hydrogen and turn into a white dwarf. A typical white dwarf is half the size of our sun and has a surface gravity of 1 lakh times that of Earth. Using the Hubble Space Telescope and Transiting Exoplanet Survey Satellite TESS, astronomers have identified several white dwarfs over the years. Now, an international team has reported a unique phenomenon in a white dwarf, about 1400 light years from Earth. They saw the white dwarf lose its brightness in 30 minutes. These gaps in brightness have been previously reported, but the process usually takes place over a period of several days to months. Where is this white dwarf? The team observed the phenomenon using NASA's Transiting Exoplanet Survey satellite TESS. The white dwarf is part of a binary system called TW Pictoris, where a star and a white dwarf orbit each other. The two objects are so close to each other that the star transfers material to the white dwarf. As this material approaches the white dwarf, it forms an accretion disk or a disk of gas, plasma, and other particles around it. TW Pictoris is located in the Pictoris constellation and binary system is about 1400 light years from us. So how does it switch on and off? The first author of the study, Dr. Simone Scaringi, explained in an email to indianexpress.com. What generally happens in these types of systems is that the donor star in orbit around the white dwarf keeps feeding the accretion disk. As the accretion disk material slowly sinks closer towards the white dwarf, it generally becomes brighter. It is known that in some systems, the donor star stops feeding the disk for yet unclear reasons. When this happens, the disk is still bright as it drains material that was previously still there. It then takes the disk about 1 to 2 months to drain most of the material, something we saw happen in different accreting white dwarfs. Scaringi is an assistant professor at the Center for Extragalactic Astronomy, Durham University, United Kingdom. Scaringi adds that seeing TW Pictoris drop in brightness in 30 minutes was totally unexpected. What we think may be happening in TW Pictoris is that instead of the disk being drained out so fast, we are seeing some sort of reconfiguration of the white dwarf magnetic field, he adds. The team notes that a process called magnetic gating may be at play. This happens when the magnetic field is spinning so rapidly it creates a barrier disrupting the amount of food the white dwarf can receive, adds a release from Durham University. Why is this finding so important? The team hopes that this discovery will help us understand the physics behind accretion, how black holes and neutron stars feed material from their nearby stars. We are running a program with tests to observe hundreds of accreting white dwarfs. This will hopefully reveal just how common or not the features observed in TW Pictoris really are, adds Scaringi. Thank you.